So, very good afternoon to all students and faculty members from various colleges. I welcome you all for the today's workshop on drone assembly and maintenance. In day two hands-on training program, we are going to understand the basic fundamentals of drone construction, configuration, maintenance, and safe operation. This hands-on training program is specially designed for beginners and intermediate learners. Throughout today's workshop, the participants will gain practical experience in assembling a quadcopter, configuring flight controllers, performing safety checks, and troubleshooting common issues. By the end of the session, you will have the confidence to build, maintain, and operate drones more efficiently and safely. This is our today's workshop agenda. Our today's workshop agenda is divided into five major modules. Initially, we begin with understanding the drone anatomy and the key components that make up the drone system. Next, we move on to the assembly laboratory where participants will build a quadcopter from a kit. Following assembly, we will configure the flight controller and learn firmware setup procedures. Then later on, we focus on safety practices and pre-flight inspections. Finally, we conclude with maintenance techniques and troubleshooting methods that help to keep the drones in peak operating conditions. First, let us understand the basic key components of drone. Before building a drone, it is important to understand its core components. The frame serves as a structural backbone and determines the drone size and its strength. Brushless DC motors generate thrust and are selected based on the kV ratings. Electronic speed controllers regulate the motor speed based on the commands from the flight controller. The flight controller acts as the brain of the drone, processing the sensor inputs and controlling the stability. Propellers convert the motor rotation into lift, while lithium polymer batteries provide the energy required for flight. The proper understanding of these components is essential for successful assembly and operation. Now let us get into the assembly lab. Here now we move into the practical assembly stage through a simulation mode. So before that, let us undergo the steps of assembly procedure. The process begins with the frame assembly, ensuring all structural components that are secured in a fastened way. Motors are mounted to the arms and connected according to the required rotational directions. Electronic speed controllers are soldered and connected to the power distribution system. A flight controller is then installed and wired to communicate with electronic speed controller and optional modules such as GPS. The receiver and camera are mounted carefully to optimize the signal quality and visibility. Finally, the battery mounting system and propellers are installed, completing the entire physical assembly of the drone. So this is just a theoretical procedure, how to assemble the drone without violating the precedence constraint one after the other. Now let us have a practical simulation assembly lab for understanding the particular segment, how to assemble a drone in a step-by-step manner. Now let us move on to the simulation mode from presentation mode. So this window narrates the drone assembly simulation. There are nearly 8 different steps to be followed for drone assembly. The first one is inventory. Unassembled parts are kept in a separate inventory. So this is the first stage. You need to assemble the frame by connecting the arms to the center plate. Next, mount the motors to the arm ends. Then wire the electronic speed controller to each motor. Install the power distribution system. Mount the flight controller. Install the propeller and the receiver. The last one, perform the final check before operating the drone. Do proper configuration, calibration, and then fly the drone in a more safe environment. So this is the last stage of the drone assembly process. So we now just witness the simulation of drone assembly followed in a step-by-step procedure. Next, we are going to see information on flight controller setup. With the complete assembly, the next step is configuring the flight controller. Using the software such as Beta Flight Configurator, we install the latest firmware and calibrate onboard sensors. Here, participants will learn how to configure receiver protocols, assign motor outputs, and verify the motor rotation directions. We also establish different flight modes such as angle, horizon, and acro modes. Important parameters including motor protocol, fail-safe behavior, throttle settings, and on-screen display elements are configured. Proper flight controller setup is most important for safe and stable drone operations. Next thing is about safety and pre-flight checks. Safety is one of the most important aspects of drone operation. Before every flight, a thorough mechanical inspection must be performed to check the frame, motors, propellers, and battery security. Electrical systems should be properly verified, including battery voltage, electronic speed controller functionality, and receiver connectivity. Software checks include calibration verification, flight mode testing, and fail-safe validation. Environmental conditions must also be assessed. Pilots should avoid crowded areas, monitor wind conditions, and legally comply with the local aviation regulations. Following these procedures significantly reduces the risk of accidents and equipment damage. So the next segment we are going to discuss about maintenance and troubleshooting aspects. Regular maintenance ensures reliable drone performance and extends the equipment life. After each flight, inspect propellers, monitor the motor temperatures, and record any unusual behavior. Weekly and monthly inspections should include cleaning electronic components, tightening hardware, and checking for structural damage. Common problems include motor oscillations, incorrect propeller orientation, battery voltage drops, etc. By understanding the above issues and their solutions, operator can quickly diagnose the faults and restore the normal operation. So, what are the common tools and equipment that are needed for performing the assembly and maintenance? A well equipped workspace is essential for drone assembly and maintenance. Basic hand tools like hexagonal type screwdrivers, pliers, wire cutters, and calipers. Soldering equipment such as temperature controlled soldering irons and flex pens are necessary for reliable electrical connections. Testing instruments like digital multimeters and battery checkers helps to verify the electrical integrity. Safety equipment including LiPo charging bags, smoke stoppers, safety glasses, and fire extinguishers should always be available. Having the right tool improves the efficiency, accuracy, and safety during drone maintenance activities. And here we are going to see another hands-on training exercise. Before moving on to the simulation mode, let us discuss all the practical exercise that provide a participant with a real-world experience. First, you will begin by practicing soldering techniques on training boards. Next, motor direction testing will be conducted using flight controller software. Participants will learn propeller balancing techniques to reduce vibration and improve efficiency. PID tuning simulation will demonstrate how flight characteristics can be optimized. Finally, a crash damage inspection exercise will help to identify the common faults and develop troubleshooting skills. These activities reinforce the theoretical knowledge through practical application. So, out of the several hands on experiments, we are going to take one basic experiments to understand the basic motion of a drone, safe landing and taking off from the ground level, from the datum point. So this is our next simulation experiment, drone flight simulator. So here we are going to do basic the motion exercise on a fully complete assembled drone. So now here the drone is about to fly in air from the particular uh, ground point. This simulation tells about the safe landing from the higher altitude to the home location. So this is the home location. The datum point is the home location. So from the given home location, how much distance higher altitude it is supposed to fly in air with greater stability and flexibility. So this is a basic exercise which tells about how drone can able to perform its multiple functional characteristics in a simulation environment. So this exercise is especially carried out to perform the safety landing and the takeoff without any structural damage and other issues. So now we will conclude the today's takeaway for based on the information given in the workshop. So as we conclude this workshop by remembering that drone expertise develops through continuous practice and learning, start with a few budget friendly builds before investing in advanced hardware. Spend time using drone flight simulators to improve piloting skills in a safe environment. Consider obtaining professional certifications such as the Directorate General of Civil Aviation Drone Pilot Certificate in India. Engage with the drone communities, participate in local clubs, and share your experiences with fellow members. Finally, I thank you all the students and faculty members for attending this drone assembly and maintenance workshop today. I will catch you up in another segment as a part of a drone skill development program. In the next segment, we are going to discuss about the pilot certification program in drone technology. Thank you all.